Hello and welcome. Today we are going to introduce you to two types of luminescence phenomena known as fluorescence and phosphorescence. Let's begin with fluorescence. So, what is it? As you can see from these videos, and you might have known from experience, some things tend to luminesce spontaneously when light is shown upon it. This phenomenon is known as fluorescence. The more formal definition of fluorescence is that it's a type of luminescence during which a substance spontaneously emits electromagnetic radiation upon absorbing electromagnetic radiation of a certain wavelength. The wavelength of the emitted radiation is usually longer and hence less energetic compared to the wavelength of the absorbed radiation, and the shift in wavelength is what makes fluorescence so useful. So how does it exactly work? To understand how, we need to go down to the level of molecules themselves. Molecules have different energy states associated with the motion of the electrons, which are known as electronic states, the stretching and bending of bonds, known as the vibrational states, and the rotation of the molecule itself, which is known as the rotational states. Fluorescence is mainly concerned with the electronic and vibrational states, together known as the vibronic states of a molecule. Let's look at this phenomenon using an energy diagram. Here, the bold lines represent the electronic energy states, and the thinner lines represent the vibrational energy states. At room temperature, molecules tend to occupy the least energetic vibronic state, which is labeled as S0 and V1 here. However, when the light of a certain wavelength is shown on the molecule can absorb the light and jump to a higher energy state both electronically and vibrationally. The molecule can then relax back to the ground state by emitting a photon of light. Usually, however, the molecule undergoes relaxation either via internal conversion, which is relaxation from a higher excited state to a lower excited state, or through vibrational relaxation, both of which release energy as heat. The rest of the energy is lost by emitting a photon equivalent in energy to the energy gap, and this is the light that we see.
So what is phosphorescence? Essentially, it's like fluorescence, the only difference being that the emission of light continues or takes place after a substance is exposed to radiation. We see it in glow-in-the-dark objects or in pen inks like the ones pictured here. The difference between it and fluorescence is that in phosphorescence, the transition begins from the lowest excited triplet state instead of the lowest excited singlet state as in fluorescence. Whereas in fluorescence, the electronic relaxation takes place from the lowest excited singlet state to the ground state. In phosphorescence, a transition from the singlet state to the triplet state, called intersystem crossing, takes place first, and then the relaxation to the ground state takes place, as seen in the diagram. A singlet state is when we have paired electrons. With a triplet state, however, we have two unpaired electrons. This transition from the singlet state to the triplet state can take a while, which can lead to a delay in the emission of light. Essentially, it takes longer to emit relative to fluorescence. During this transition within phosphorescence, there is a loss of energy, which accounts for phosphorescence's longer relative wavelength.
Applications of the fluorescence research began in as early as the 1940s with anti-malarial drugs which fluoresced at certain UV wavelengths. Areas of research and application continued to grow steadily as time passed, and we saw the applications of the fluorescence method become ingrained into our everyday lives, from the light bulbs in our ceilings to the highlighters we use for notes. Fluorescent light bulbs work by ionizing mercury vapor in a glass tube. This causes electrons in the gas to emit photons at UV frequencies, and the UV light is then converted into standard visible light using a phosphor coating on the inside of the tube. Certain plastic utensils are made with fluorescent dyes to give them a fun and vibrant appearance. In U.S. notes, fluorescence is added to the security strip built into the paper, and in 1996, a new ultraviolet fluorescent compound was added into the security strips, which, when exposed to ultraviolet light, produce a unique color for each domination. Fluorescent highlighters use the process of fluorescence to produce vibrant and translucent colors that stand out amongst plain text as well as other colors. Another common household appliance that uses fluorescence, believe it or not, is your television. Most modern televisions are made with what we call quantum dots, which are man-made nanoscale crystals that can transport electrons. When UV light hits these semiconducting nanoparticles, they can emit light of various colors. Quantum dots are capable of high brightness, they have a resistance to photobleaching, and have a tunable wavelength, all characteristics that make this invention a potential candidate to be used in cancer imaging.
Like its early application in anti-malarial drugs, fluorescence has become highly ingrained in medicinal practice. The fluorescence method led to the invention of fluorescence microscopy, which is a powerful tool that allows the specific and sensitive staining of a specimen in order to detect the distribution of protein or other molecules of interest. Boring methods of fluorescence microscopy, researchers have discovered particular fluorescent dyes that are useful in creating clear images of tissue and blood vessels. Additionally, fluorescence in situ hybridization or FISH is a method capable of inducing genes from genomes by covalently bonding to the gene and then placing a light on it for identification.
By understanding fluorescence and how it works, we have successfully integrated it into much of our daily lives, as well as making breakthroughs in medicinal research and coming up with new ideas and techniques that will revolutionize the way we see and do things.
Thank you for watching our video.